Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be comparing and ordering decimals. Before we do, let's look at a definition. So, a decimal is simply a rational number that represents part of a whole. The part is base 10. All decimals can be represented on a number line. So, for example, if you had the decimal 1.5, you have one whole and 5/10, or you have 1.5 of something. All right. In fifth grade, you learned how to use a number line to plot and compare and put decimals in order. So some of this will be very familiar to you, but in sixth grade, we're going to be adding negatives onto your decimals. And we'll talk about that and how to do that in example 1. So in example 1, it says use the number line below to plot and label the points in group A, then plot and label the points in group B. So in group A, we have point A at -5. So I'm going to find the -4, and then they didn't draw it in, but we can extend our number line here and say that point A is at -5. Point B is at -3. Point C is at +1, and point D is at +3. Now, what I want you to notice is that all three of these numbers were integers. They were either a whole number, 0, 1, 2, 3, 4, or an opposite of a whole number. All right. In our next group, we're going to be plotting decimals. So now we're going to be plotting numbers that are between the whole numbers. All right, so let's look at our first point, point E, 0.4 or 4/10. Now, what I want you to notice in this number line is it is scaled by 0.5s. So this first, if my tick mark is 0, then my next tick mark would be 0.5, and then 1, 1.5, 2, 2.53, 3.54, and so on. Now, we can also do the same thing on the negative side of our number line. If we have 0 and we go to the left, we would have -0.5, -1, -1.5, -2, -2.5, -3, -3.5, -4, and so on. All right. So if I wanted to plot E at 4/10, I would want to put that, and I'm going to put this in red, I would want to put it right before the 0.5 because 0.4 comes before 0.5. So this is point E, and it would be 0.4. All right, 3.75. So here's 3.5, here's 4. It would be halfway between the 3.5 and the 4. Point F, 3.75. All right, G, -0.25. So find the 0 and then go to the left. Now think of money. 25 cents is half of 50 cents. So -0.25 would be halfway between the 0 and the -0.5. So -0.25 would be this point right here. All right, and then -3.75. So find the -3.5, and it would be halfway between -3.5 and -4. So that's point H, -3.75. So I'll draw an arrow to that. So now we've plotted the decimals. So notice all the decimals were in between the whole number. So sometimes we had to kind of estimate where to place them. All right. In example 2, it says, plot the numbers below on the number line and then fill in the circles with either greater than or less than symbol. All right, so point A is at -4.2. So I would want to go to the -4 and then a little bit to the left of that. There's point A, and I'm going to label it -4.2. I'll draw an arrow there. All right, B, -3.3. So go to the -3 and a little bit to the left. That would be -3.3. All right, 1.1. So go to the 1 and then a little bit over. So that would be point C, 1.1. 2.05 or 2 and 5/100ths. that would be just barely past the 2. That's point D, 2.05, label that. And then negative 1.9. So find negative 1 and then go to the left almost to the negative 2. So negative 1.9. All right, now we're going to use either a less than or a greater than symbol to compare the two numbers. So let's look at problem A. We have 1.1, let me highlight that, is being compared to negative 3.3. So because 1.1 lies to the right of negative 3.3, that means it's bigger than or greater than. All right. Let's try problem B. In problem B, we're comparing negative 4.2 to negative 1.9. So because negative 4.2 lies to the left of negative 1.9, we say that it is less than. Negative 4.2 is less than negative 1.9 because it lies to the left of negative 1.9. All right, problem C. Negative 3.3, highlight that, compared to 1.1. Well, negative 3.3 lies to the left of 1.1, so it is less than 1.1. In fact, a negative number will always be less than a positive number. A negative number will always be less than a positive. All right, pause the video and try problem D on your own. All right, welcome back. Let's see. We compared negative 3.3 to negative 4.2. So because negative 3.3 lies to the right of negative 4.2, it is greater. So negative 3.3 is greater than negative 4.2. All right, example 3. Plot the numbers below on the number line and then order them from greatest to least. So let's start by plotting them here. We have A at negative 0.25. So here is negative 0.5. So negative 0.25 would be halfway in between. That's point A. And I'll label it negative 0.25. All right. Point B, negative 3.2. So here's negative 3 and go a little bit to the left. Negative 3.2. Now negative 2.4. Find negative 2 and then go here's negative 2.5. So negative 2.4 would be almost to the negative 2.5. So negative 2.4 would be this point right here. All right. Problem D, 0.2 or 2/10. Find the 0 and go a little bit to the right. That's point D, and I'll label it 0.2. Point E is 0.86. So here's 0.5, so I'm going almost to the 1. So that would be point E, 0.86. All right, now they want us to put these numbers in order from the greatest to the least. Now remember, on a number line, the largest numbers are all the way to the right. So our point that was furthest to the right was point E. So that was 0.86 or 86 hundredths. Then our next point was D, which was 0.2 or 2/10. Our next point was A, which was negative 0.25. Then our next point was C, negative 2.4. And finally, our very, very smallest point on this graph was point B, or negative 3.2. All right. Example 4. The table represents the number of pounds a boxer gained or lost each week. List the values in order from least to greatest. So this time, they're wanting us to put the smallest number first. So when you have positive and negatives, the smallest numbers will be the negatives. The smallest numbers will be the negatives. So of those two negative numbers, I want to put the smallest one first. So that would be negative 0.86. The next smallest number would be negative 0.25. All right. Then I'm going to put the rest of my numbers in order. I have 0.3, 1.02, and 0.18. Well, I know 1.02 is the largest. All right. So I have to figure out the order of the other two. So I would have to put 0.18 and then 0.3. So there are the numbers in order from least to greatest. All right, example 5. Madi used a thermometer to record temperatures of negative 3.4 degrees Celsius and 1.6 degrees Celsius. Which temperature in degrees Celsius is less than both of the temperatures Mari recorded? So I want a temperature, I'm just going to use a little question mark to represent, that is less than negative 3.4, which is less than 1.6. In other words, this would be the least one, and 1.6 is the greatest. So I'm looking for a temperature that's smaller than negative 3.4 and 1.6. So I'm automatically going to eliminate B because 3.9 is bigger. Okay. I'm also going to eliminate 0 degrees because it's not smaller than negative 3.4. All right, it has to be either A or C. Pause the video and try to determine whether it's A or C. All right, welcome back. Hopefully you chose answer C because negative 5.4 is smaller than negative 3.4, which is smaller than 1.6. All right. Example 6. Which value represents a decimal between 0.11 and 0.17? So in other words, our smallest number is 0.11, and then I want a number that's in between. It's got to be bigger than 0.11 and smaller than 0.17. So what I want you to notice that both of these start with a 0.1. So I can eliminate A, D, and C because those are not bigger than 0.11. And to make this statement true, the number has to be bigger than 0.11 and smaller than 0.17. So now I'm going to eliminate F because that's 0.18. So that's not smaller than 0.17. So the only two that are between 0.11 and 0.17 are B, 0.159, and C, 0.123. All right, example 7. Use the answer choices to make the inequality true. So we have 4 answer choices, 0.125, negative 4.5, 0.025, and 1.9. So here's our inequality. Our smallest number is negative 2.6. So I'm going to put, this is our least. And then it's less than 0.10, which is less than 1.7. So this is our greatest number. So let's look at this box first because I think it's easier to work with the positives first. Let's look at this green box first. I want a number that's bigger than 0.10, but it's smaller than 1.7. It's bigger than 0.10 and it's smaller than 1.7. So I'm going to get rid of 1.9. This answer has to be eliminated because it has to be smaller than 1.7, but bigger than 0.10. So I'm going to go with 0.125. All right, so now we've used up that number. All right, now our next number has to be bigger than negative 2.6 and smaller than 0.10. So I'm going to get rid of this number because it is not bigger than negative 2.6. So the only thing it can be is 0.025. And that concludes today's lesson, comparing and ordering decimals.